So, welcome folks, my name is Muted Mouse, and I'm the author of TA Volatility, and today we're going to be covering how to get data into TA Volatility using the copy method. So this is not using a universal forwarder, and this is not analyzing directly on the Splunk server. This is using a SIFT workstation, which we'll have as System A, and we'll have System B, which is the Splunk server. And we'll be doing our analysis outputs on System A, the SIFT workstation, and transferring them via secure copy or SCP over into the Splunk server System B, and we'll also be able to see when Splunk picks those up. So some of the main things to keep in mind are we're not going to cover how to install Splunk, we're not going to cover how to do all the basic setups. This is purely for TA Volatility. So before we go too deep into all of this, I'd actually like to give a couple major shout outs to some people who have had a lot of work on this project with me. One is Chris Burch. He goes by the name Dragar on Splunkbase, and the other is Sandeep Vasani. Chris Burch went and did a lot of the work for all of the parsers and the plugins and everything that does a lot of the back-end work for Mac and Linux. And Sandeep wrote us the listprocess child process walker custom command, which you guys will be seeing in the demo. So let's go ahead and get right into it. Alright, so first thing we're going to do is find out where we are, and then we're going to look at the directory, and we see we have the advanced memory forensic samples.zip. We're going to go ahead and we're going to unzip that file. And we're just going to pull out one of the sample files. We've already done the unzipping for you, so you don't have to sit there. We're going to be working with sample 001.bin, which I believe is a Windows XP Service Pack 2. We're going to go ahead and look at it. As you can see, the file command gives us basic data, right? It's just binary pack data. So we're going to have to do a little bit more with this. Let's clear that screen out so we can get working with something. So we're going to git clone the volatility fork that myself and Chris Burch have created. It's just a basic fork of volatility. You can find it at github.com/mutedmouse/volatility. Really, there's no major difference between our fork and the real volatility. The real volatility, as the master has it up on volatility, does not have some of the JSON parsers that we've written, and we've also added in like a Mac PPID capability. So that's pretty nice for being able to go back and forth between files. Right now, we're going to go ahead and we're going to do a git clone of the TA volatility, and really, this is just to show you how many parsers we support, or how many you can check and see if we support, or if you want to go in, you want to see if there's a plugin that you as a community member have that we don't currently support. So let's go ahead and let's go into the volatility and let's install it with python setup.py install. What that's going to do is that's just going to do all the eggs, all the distro setup. So this lays a good foundation for knowing your volatility plugins and the stuff that's available to you within that. Alright, so now we're all done with that. Let's go ahead and do some vol.py work. So the first thing you want to do is vol.py tach. Make sure that it reads 2.6. That's very important. I goofed up and I gave it like a head 1 instead of a head tach n1. So this is going to tell us, hey, this is volatility 2.6 and generically how to use it. Really, we're only going to cover the commands out of volatility that are important. 2.6 is the only version that started supporting JSON outputs. So we're going to do vol.py tach, which specifies the file. We're going to specify Windows sample 001.bin. And we're going to run image info. Alright, so background on image info, if you're not familiar with it, image info is going to tell you what profile you should instantiate all follow-on analyses with. So it looks at the KDBG, it looks at the DTB, it looks across the memory image to see which volatility profile should apply to this memory image. If you don't have a profile that matches it, then it's probably going to kick back and go, hey, you're dumb, you need to go download this profile, in which case you'll need to make a profile. Now that's a pain in the butt, so if you have to do that, I'm sorry for you. We don't support how to do that in TA Volatility. TA Volatility is just analysis. Alright, so that output's done, and as we can see right off the bat, we know that this is probably a Windows XP Service Pack 2, 86, or Windows XP Service Pack 3. They did do Windows XP Service Pack 2, x86, so we're going to roll with that one. Always start off with vol.pytacf unless you specified a volatility RC. And we're going to use a sample 001. And this time we're going to use image info, but we're going to show you how to dump it with JSON. And afterwards, I'm going to freeze it real quick. So you use tac output equals JSON. And this is going to dump out Volatility's interpretation of JSON. And it's very important that we have a good, solid foundation of what JSON is in terms of RFC and what JSON that is dumped out from Volatility. Because the two are not equal. Standard JSON is going to be a dictionary of lists of dictionaries, right? Very clean cut. Every element has a key associated to it. So stream outputs where it's the session, there's the ID, there's the source port, the destination port, and every one of them are keyed. You'll notice here what Volatility has done is they did rows colon and then a list of lists. If you tried to import this directly into Splunk as is with pure JSON, it would simply come in with rows and columns. Splunk's not going to like that very much. And standard screen output isn't really going to help us. So what we're going to do is we're just going to make a directory for these outputs. Now, you're going to need this directory when you actually start doing a lot of your analyses. So always make it based on the host name or the image name. It helps, trust me. Now, what we're adding into our command from earlier where we did tac output equals JSON is we're going to add tac output tac file equals, and then we're going to give it the folder we just created, which is the host name, and the plugin name.json. You'll see when we go into the app setup page that this format is critical. This is what TA Volatility is looking at when it starts to ingest things. It's looking for a host name and then followed by the plugin name. So please follow those naming conventions and you won't steer yourself in the wrong direction. Okay, so now we're just going up one folder and we're going to go look at that sample 001 folder and we're going to look at imageinfo.json. And you'll see it has 522 bytes of data. That's really going to be useful because TA Volatility intentionally ignores 0-byte or file part files. So now let's get into running some real plugins. Let's run vol.py with the profile that we just copied a little bit earlier while we were waiting for the other one to finish. We're going to run ps list. Now ps list is process listing. And you'll see that's a really pretty output. But sometimes you get tabs and sometimes you get spaces. And sometimes it's pretty and sometimes it's not. Well, let's output it to JSON. And you'll see again, we run into the same problem. This is custom formatted JSON and not Splunk ready JSON. So let's output it to a file exactly as we did with image info. And we're going to dump it to the same folder with the plugin name.json. And that's going to go ahead and that's going to fly out there. Image info actually takes a lot longer than the other plugins because it has to look for all those pieces of the kernel information inside the memory. So it has to match that profile. PSXView is another really good utility to go ahead and hunt in memory. What it's going to do is it's going to run 7 different plugins and look to see whether or not the name and the PID were seen in each of them. So this is where you can see whether or not like service host was seen in one. It was only seen in one of the 7 plugins. That might be something to look into. It might not. Let's go ahead and output it as JSON. And this is just to show yet again that JSON output is painful to deal with directly. So yet again, we're going to go ahead and run that. And we're going to do the tac output tac file equals, remember, hostname or memory sample name, not JSON, hostname or memory sample name dot slash the plugin name.json. Again, this is how Splunk is how TA Volatility is going to try and pick it up. every now and then you are going to get errors. You are going to get things that just don't run right. It happens. Send us a bug report and we'll go ahead and look into it. So without doing the whole shebang, we're going to go ahead and run malfind. You guys have already seen the standard output, and you guys have already seen the JSON output, so we're just going to run malfind with an output file. What the malfind will help you do in Volatility is it will help you find injected DLLs. It's going to look for mismatched memory segments where there's two private segments, and it's going to try and output all of that to you, and we'll actually see some of that. So right now we're actually going to run a plugin that does not support JSON, and this is where we would file a request. So if you ever get an output like this, and it is possible, screenshots are probably not possible, go ahead and submit a pull request or submit an issue into the TA Volatility GitHub, or shoot us an email at the dev link on Splunk base, and we'll go ahead and try and take care of it. Alright, so here we're just going into the TA Volatility folder that we cloned a little bit earlier. I had forgotten. And we're going to look for any Windows, any Linux, or Mac underscore files inside the bin folder, which is where we store all of our Python scripts. And we're going to dump out a ton of them, right? That's a lot. So let's just word count it. And maybe we wrap that into a pretty little bash script. So a little bit of bash jujitsu for everyone. We're going to go ahead and show how many plugins we support just by nested ls. Yeah, I know this is kind of unnecessary, but you know, little cools every now and then. So now we're getting into, let's check our networking and make sure that we're able to reach our Splunk server, which, if I'm not mistaken, was sitting on 192.168.128.10. And we can see that this system is sitting on 192.168.128.11. So can we ping 192.168.128.10? Yes. All right, we're all set on system A. Let's move on over to the Splunk server. So I'll do our quick little login. And we did a nice little cleanup earlier just to make sure that everything was prepped for this demo. So that's all you were seeing there. We'll do a quick ls and make sure that you can see that there's no TA Volatility and there's no Sankey app. So we're going to go to our home directory and we're going to go ahead and see what we've got in here. Now, I already have downloaded the TA Volatility, and this is the 2.6.3 SPL that I created when we were doing Splunk package app TA Volatility. So we're just going to go ahead and install it that way. I'll go ahead and start Splunk and do everything through the GUI instead of trying to do it in the back end and force restarts. Now, side note, while this is coming up, TA Volatility does require a restart. Technically, it fires the you need to reload right now, but in the back end, it's actually doing exactly what it needs to do, how it needs to do it. So you really don't have to restart, but whenever installing an app that says you need to restart, probably a really good idea to restart it. Future iterations, we're going to take out that trigger message and we're just going to let it go. So let's log in with admin change me, and as soon as it comes up, we'll go ahead and we'll move over into our apps section. I always get lost on this part. So let's manage our apps. We're going to go ahead and wait for that page to load. Sorry, I had very under-provisioned the system for this demo. It's going to be a little slow. We're going to install app by file. Let's upload the app. We already have that in our home folder. So we're going to go over to our Grimlock home folder, scroll down, hit our TA Volatility, and just double click. It's going to tell me I need to restart, but you know, I'm lazy and I'm not going to restart right away because I'm also going to install the Sankey app, which we'll be demonstrating in a little bit with process relationships and how processes spawn. So that'll actually be really cool. and it's gonna be well worth it not to restart right away. So let's go ahead and restart later, and we'll go ahead and upload our Sankey app. Now, I've already downloaded the Sankey app. If you don't already have it, I would highly suggest going out to Splunk Base and pulling down app number 3112. That is the Sankey diagram visualization app, and that's what's going to show us the actual logical flow of what process spawned another process. So we're going to go ahead and hit upload, and now we'll go ahead and do our restart, since we've installed both the TA Volatility and the Sankey app that we're using for the demo, so we're all done with that. So now let's go ahead and select OK. We'll get back into it. Let's log in with our username and password. And once we're all the way in, we're going to go to the launcher page. If you drop down the box, you'll go ahead and see, yeah, TA Volatility is there. But, just for demonstration purposes, we're going to go through the main launcher page. So if we click on the TA Volatility, we're going to go ahead and pull up the app. Now, this app comes with a configuration page. So if you haven't already run through the configuration page, app.conf is not configured. This is going to walk through creating the vol.conf file that you'll need and configuring the app.conf to go ahead and register the app as configured with your Splunk server. Now over here on the right side of the screen, as we'll highlight, you'll see the required folder structure for TA Volatility to pick up your JSON outputs. Here we have a required base directory path. It could be 8 folders deep, it could be 1 folder deep. Please don't store it on the root of Windows, so don't store it on the C:, because it looks in a Windows folder. And you don't really want this looking through Windows. So what we're going to do is we're going to define, let's say, whack data, whack memory, and then we need a Windows, a Linux, and a Mac folder. And then underneath that, we're going to have a folder named after the subject, host name, or memory image. And underneath that folder, we're going to have the plugin name.json. So this is why we had you create those folders earlier over on the SIFT Workstation. Because when we transfer those folders in, we're going to transfer the entire hostname folder into Splunk on System B, and it's just going to pick it up like it was magic. And now if you look on the left side of the screen, which is highlighted, you'll see the setup properties and a text box right underneath that. Once we're done in the command line creating the directory that Splunk is going to start, that TA Volatility is going to start at for looking for these plugin JSONs, this is where we'll put that folder path, and then when we click perform setup, it's going to put that folder path into the app, into the vol.conf file inside the local folder of TA Volatility. Now, each of our Python scripts that handle parsing those JSON outputs back into tab separated format is base directory that is read from this vol.conf. And that's why it's very important that this folder be correct. So now that our base directory is all set up, we're going to put in whack data, whack memory, which we just created and owned by Grimlock, and we're going to go ahead and perform setup. What this is going to do is this actually triggers a reload function of Splunk, so we're going to go ahead and do that, and when Splunk comes back up, we'll start the copy from System A, SIFT Workstation, into the folders that we just created on Splunk System B. Alright, so now that our Splunk server is restart, we're going to drag it over so that we can see both screens. We set up a watch screen over on the right side so that we can see the files come in and when Splunk reads them and deletes them. Once it has read a file that it has determined is a volatility JSON output with the proper plugin name, it will delete it to prevent a double ingest. So please be aware of that. It's a feature, not a flaw. So we're just going to load up the search page, and then we're going to go back over to System A, because now it's time for us to transfer all the files in and get this ball rolling. Alright, so now that we've verified that the search page is loading, we're going to go back over to our System A, and we're going to go up. Remember, we left out where we were in the TA Volatility folder. So let's go up 2 folders, and we're going to be in the main SANS Forensics home folder. We're going to take sample 001, and we're going to SCP, or secure copy, recursively that entire folder over to Grimlock at 192.168.128.10 whack data whack memory whack windows. So remember, we're going to follow that entire folder path, and we're going to stick it all the way down where Splunk is already going to be looking. And we're going to go ahead and fire that off. Now remember, we're doing this secure copy runs over SSH, so we're going to need to put in our password, and there we've transferred the files over. So now, quick lickety split, back over to System B. There's all the files. All right, cool. And you see they've already gone away, so Splunk has already picked them up and started moving on. So now we're going to go ahead and run our search. And if I'm not mistaken, we have already selected this search for all-time real-time. We're going to say index main source volatility, which is default inside the inputs.conf as it stands right now. And we're going to say, hey, stats count by our source type. Now, if I set this to all-time real-time, or if I set this to all-time, which I didn't, and now we have, we're going to see all these source types just came in. So Splunk just started picking all these up with the TA Volatility. These scripts run every 30 seconds. And be it known, for those who may care, that these scripts will look iteratively to see if each condition is met before going forward. So let's look at the source Windows PS list, or the source type Windows PS list. And yeah, we see some really sweet process listings down there. Those are really nice, but again, not really helpful to a hunter. So what if we tabled them? Image is actually the name of the folder that you stored everything in. So that's where it picks up the image name. That's our unique identifier for the system that was processed. So why don't we start making this really interesting, and let's build out our Sankey diagram search. As it stands right now, we're using a sub-search to build out the PPID name association. But I would highly recommend using a generated lookup table from the name and PIDs. Much more efficient and goes above the 10,000 sub-search limit. So as we build this thing out, we're going to be joining image, name, and PID renamed to PPID and name renamed to PName into the original image, name, PID, and PPID. And what this is going to do is this is going to take the names of each of the PIDs that appeared elsewheres, and it's going to drop them into our original search. Odds are I probably don't, in a Windows system, have 10,000 processes running. If I did, that would be really bad. So if we go ahead and we fire the stats count by now, name and PName, which is the parent name and the child, we get this really sweet output of name and parent name. Let's flip it around so we have parent name and name. All right, and let's format that search up a little bit. Let's prettify it. And now, that's a sweet column chart, but what if we went down here and we selected the Sankey diagram? So now we actually get the process flow of the parent and the children as they occurred inside the system. Very cool, right? If you saw something like command.exe over there on the top left, you can tell command.exe fired off MDD, fired off Explorer. That's really awkward. Explorer shouldn't be launching from mdd.exe. It'd be very easy for an analyst to tail this all down. Now, what if we wanted to go one step further? What if we, instead of just seeing the name of the process, also wanted to directly associate the PID and the process? Well, let's go ahead and use an eval statement here, and we're going to go ahead, since we already have all our values, we're going to eval PID name equals toString the PID plus colon plus the name. And we'll do the exact same thing with ppid. So we'll make ppid name, and that's going to be a toString ppid plus colon plus pname. Now you'll see very quickly what this ended up doing is giving us a surgical granularity view of that same data set. You'll notice that 1796 command.exe fired off PID number 244 mdd.exe, which then fired off PID 284 explorer, and then launched xmsimn msmsgs, which is not msgss or SMSS. There's too many S's, and CTF mod. There's clearly something that happened during command.exe and then followed on into MDD and followed on into Explorer, and then launched other processes to appear like a legitimate process. What's even more bothersome about this are the base processes of SMSS and WinLogon and services are all low PIDs, where command.exe is a very high PID, which indicates that it may or may not have come from userland. Definitely came after SVC host. May have come after walkout, and really it looks like it was one of the last processes to be launched. If we go down, it'll also do some syntactic highlighting for us. So command.exe at this point is a very suspect process on the system sample 001.bit. And we can see that very quickly from this cursory examination. Alright, so that's enough of looking at that. Let's go ahead and take a look at another really useful plugin, PSXView. Now, PSXView looks across, like we talked about, those 7 different sections, and it looks to see whether or not each of those different plugins saw or did not see the name and the PID and the offset. So, if we load up PSXView, you're going to see just a metric ton of stuff come up, right? Normal user, not really going to stare at it. It's not in tabular output. It's not clean. Well, we're going to clean it up. Well, first things first, we got to figure out what fields we need. And as we just hovered over there on the left side of the screen underneath your all fields examples, you can see there's some fields that are pretty common that got picked out for us. So why don't we start building a table off of these fields? And we just expanded this thing out because it's easier for us to see them in this single field or in this single element than to just go ahead and try and pick and choose from them. And then really janky way to do it, but I copy and paste every now and then to build my fields instead of just doing a giant table splat. These are the other 4. So we're going to go ahead and just drag those, and we're going to copy and paste them up. And we're going to do some cleanup on these commas and such, and then we're going to launch this thing off. And hopefully what we get is the tabular-ish output that Volatility would have given us, but in Splunk, with correlation to other data sets if we so chose. So let's count up our fields, make sure we got them. And yeah, that looks like 7. So why just tabular output when we could actually build a counting mechanism to highlight the significance of certain PIDs and names by counting up each of the fields with a for each? Now, before you say it, I already know. I goofed. My for each doesn't actually have all the fields in it. We're going to come back to that after I run it and it fails. But we'll keep on adding a rating increment if the field that we're analyzing is false. And at the end of it all, what we're going to end up with is we're going to have a count of how many fields, how many plugins PSXView implemented that did not see this process, which is going to tell us these are the ones that you should go look at. So, yeah, there it is. I was a dingling. Completely forgot to paste in my fields. So we're going to go ahead and paste those in real quick. And when we run this thing off, we're going to have a list over on our far right side that's going to tell us the numerical significance of this process as opposed to all the other processes. And we'll click that rating thing real quick and flip it up. So now we can see very quickly when logon has a 6. When logon is actually not that bad. However, that same command.exe, that 1796 that we saw earlier, that has a count of 6. We probably want to go take a look at that. So these are the types of hunting things that you can do once you get the data into Splunk. So folks, thank you for taking the time out of your day to watch this tutorial on how to get your data into TA Volatility. If you have anything at all, questions, comments, concerns, complaints, gripes, plans for amazing introductions into this application, if you have an idea that'll change the world, if you have something that you want to see implemented, some awesome hunt that you normally do in Volatility, anything at all, please shoot us an email at the dev email. Go ahead and leave us a like on Splunkbase. Let us know that the work is appreciated. Send us a pull request for any implementations. If you wrote a community plugin and you want to see it supported, send us the plugin information. We'll write a JSON formatter for it, and we'll write the Python on the back end to be able to handle it and get you supported. And if you guys have anything at all, just let us know. We'll publish another video and some sample data so you guys can start searching against that without having to format and import your own data. So please stay tuned. We'll have more to come.